Okay, image formation by lens. Okay, so here we want to talk about lens. So what is a lens? Okay, lens is a piece of transparent material which has two surfaces with at least one surface curve. Okay, two surface, at least one of them is curved. So there are two types of lens: convex lens and concave lens. So the first thing that we need to learn is how to identify convex lens and concave lens. Okay, so convex lens is a lens where center is thicker than the side. So for example, okay, any lens where the center is thicker than the side. So for example, this one, you see the center thicker than the side. So that means this is convex lens. Okay, this is convex lens. Concave lens is the lens where side thicker than center. So for example, this one side thicker than the center. So this is concave lens. Okay, so this one, label the lens below as convex or concave. So this one is center is thin, the side is thick. So that means this is convex lens. Okay, this is convex lens. This one, center thick, the side is thin. So this is, this is concave. So this is convex lens. This one, center thicker, the side thin. So this is convex. This one, the center is thin, the side is thicker. So this one is concave. Okay? Get the idea, okay? Convex lens. Alright. So don't care what kind of shape of the lens that they give you, the question give you, don't care what shape. You just follow this rule of determining whether it's convex or concave, then you will have no problem identifying which is convex lens, which is concave lens. Okay? Alright. Okay, so next there are some names that we need to learn about this lens. Okay, because you see this is actually what we call a ray diagram. Okay, this is what we call a ray diagram. So the ray diagram shows us the pathway of the light ray. When the light ray go to the lens and pass through the lens, what will happen to the light ray? Okay, where will the light bend? In which direction? So that is the purpose of the ray diagram, to show us the path of the light. Okay, where will the light go after passing through the lens? Okay, so in the ray diagram for lens, there are a few names that we need to know Okay. Okay, first is the center of the lens. This center of the lens, labeled as O, is what we call the optical center. So optical center is the point at the center of the lens. Light ray pass through optical center are not refracted. Okay, we take it that the light ray, if the light ray pass through the center, it will not be refracted. Okay. Principal axis is this line that pass through the optical center. Okay, the line that pass through the optical center, pass through the optical center and also pass through the focal point. This line at the center here we call the principal axis. Okay, So principal axis, straight line through the optical center and center of curvature of both surface of the lens. Okay, so what is center of curvature? Okay, what is center of curvature? Center of curvature basically means, I want to explain what is center of curvature. Okay, so because the lens is curved, okay, for example, convex lens is curved. So this curvature, okay, let's say this curvature is part of a big circle. You see or not? Okay, this curvature here is a part of a big circle. This curvature here also another part of the big circle. Okay? Okay, so the center of curvature here refers to this center. Okay, the center of this circle where it formed the curvature. Okay? So this center, so this is what we call the center of curvature. Okay, so for this surface, the center of curvature is here. Okay, the center of curvature. So for a lens, the two surface, the two curved surface, it can have different. The curvature can be different. Okay, the curvature can be different, not necessarily the same. But what we learn here is we don't go so advanced. Okay, so that means we don't think about something that is so complex, or what happens if the two curvature is different. No, you don't have to think like that. Okay, we take it that all the lens that we learn here is we consider as both sides have the same curvature. Okay, the degree of curvature is the same for both sides. Don't care whether it's convex or concave lens. Okay, so concave lens also have curvature. So same thing. You see this surface curve looks like it's a part of a circle. Looks like it's a part. So this is the center of curvature for this surface, and this is the center of curvature for this surface. Okay, like that. So concave lens also got. Okay, so that is what it means by center of curvature. Okay, so principal axis is a straight line through the optical center and the center of curvature of both surface of the lens. Okay, for axis of lens, straight line through the optical center and perpendicular to the principal axis. So this is axis of the lens. This one center here. This one is the axis of the lens. Okay, straight line through the optical center and perpendicular to the principal axis. So 90 degree. Axis of lens, 90 degree with principal axis. Okay, object distance, U is the distance between object and optical center of a lens. So that means like this. Okay, this is the lens. So let's say there is an object here. Okay, so this distance. Okay, this is axis of lens. So the distance from the axis to the object So this is the object distance. Okay, if the lens form an image, okay, let's say there is an image here. Okay, image. So the image distance is same also from the image to the axis of lens. And the symbol for image distance is V. Okay, image distance V. Okay. Alright, so next is the focal length. Focal length is the distance between focal point and optical center of a lens. Distance between focal point and optical center. So this is the focal point. Okay, so here to here, this is the focal length. The symbol for focal length is a small f. Okay, italic small f. Alright, so so here, okay, focal length. For concave lens also have, okay, focal length. And then focal point. Focal point is point located at principal axis of a lens where parallel light ray will converge to. Focal point of convex lens is real because refracted light converge at this point. So the focal length is positive. That means the focal length for convex lens is, we consider it as a positive focal length. Okay, so what does it mean is like this. You see, we got light that is parallel to the principal axis. After pass through the lens, all of the light ray will converge. It will all go through the single point. So this point is what we call the focal point. Okay, this is what we call the focal point. So all the light actually pass through this point. So that is why we say that this point is a real. Okay, this is a real focal point. All the light really pass through this point. Okay, now we look at the concave lens. Concave lens. Okay, for concave lens, you see the light will diverge. Okay, the light diverge when passed through the concave lens. So the focal point for concave lens is a point located at principal axis of a lens where parallel light ray will appear to be diverging from. Okay, appear to be diverging from. So you see the light all diverge. So if your eye is here, it will look like the light come from this point. Right? Okay, if you look, okay, from the point of view, if you look at the light, it looks like all of the light come from this point. Okay, it looks like the light come from this point. So that is what it means by where parallel light ray appear to be diverging from. So this point is the focal point of concave lens. So focal point of concave lens is virtual. That means not real, virtual, because refracted light ray appear to diverge from this point. That means it only appear to be, looks like diverge from here, but actually here there is no light come from here. That means this 1, 2, 3, 4, 1, 2, 3, 4, 5, this 5 ray of light looks like come from this point, but actually they do not come from this point. This light number 1 come from here. This light ray number 2 come from here. Light ray number 3 come from here. Number 4 come from here. So this 1, 2, 3, 4, all of these light do not come from F, but if you look at the light ray, it looks like it comes from here. That is why we say that it appears to diverge from this point. So we say that the focal point is virtual. Okay, the focal point of concave lens is virtual. Okay, so the focal length is negative. So basically this number, whatever this number is, we put a negative. Okay, let's say that this focal, let's say this distance here to here is 10 centimeter. Then later on, this is we only put the negative when we want to do calculation. Okay, when we want to do calculation with the focal length, then we put a negative to the focal length of concave lens. Okay. Okay, so convex lens are known as converging lens because it converges the light. So we call it converging lens. Concave lens are known as diverging lenses. Okay. So